Chapter 9.2 Notes, Sum and Difference Identities. This is page 3. So example 4 at the top of the page looks a little different. It's asking for the exact same thing we had before, finding the exact value of the sign of a sum. But here, the sum looks a little different. We've got inverse cosine of 1/2 and inverse sine of 3/5. So first things first, this is the sine of a sum. So I'm going to write that formula out so I know exactly what it is I need to find. And so we've got what? Sine alpha plus beta is the sine of alpha times the cosine of beta plus, operation stays the same, cosine of alpha times the sine of beta. Okay? And I'm going to make this my alpha and this my beta. Okay? I don't know what alpha is, nor do I know what the sine of it is. So I'm going to start by going back to some of what we did in the last chapter. And that is draw a triangle based on the information that I have. Okay? So let's stick my first triangle right, let's color code. We're going to make alpha green here. And so I'm just going to draw my triangle, keeping in mind that orientation does not really matter. And I'm going to make this angle right up here my alpha. Okay. It says the cosine, inverse cosine is 1/2, or sorry, inverse cosine of 1/2. That means that the cosine of alpha would be 1/2. And so cosine is adjacent over hypotenuse, just the reminder there. And so if this is my alpha right here, my adjacent is 1, my hypotenuse is 2. And then I'm going to go ahead and use the Pythagorean theorem to find this opposite side. Okay, a squared plus 1 squared would equal 2 squared. So I've shortcutted and written both of the numbers that we know on the same side. I got 4 squared minus 1 squared equals a squared. A squared is 3. So a is the square root of 3. Okay. That means that I know that if my cosine of alpha is 1/2, my sine of that same alpha is square root of 3 over 2. And this looks somewhat familiar, right? We have places on the unit circle where the cosine is 1/2 and the sine is square root of 3 over 2. I am going to do the same thing for beta. We'll stick our beta in purple. Again, doesn't really matter what the orientation of my triangle is, as long as I draw it so that I've got that right angle in there. I know that the inverse sine of 3/5 is my beta. That means that sine of beta is 3/5. Sine is opposite over hypotenuse. So from my angle beta, I'm labeling my opposite side 3. I'm labeling my hypotenuse 4. Because we're super comfortable with our right triangles, this has to be labeling the hypotenuse 5. Sorry, I was speaking ahead. And because we are familiar with our Pythagorean triples, we know this has to be a 3, 4, 5 right triangle. Okay. Where the sine of beta is 3/5, has to be, that's what we started with. And the cosine of beta is 4/5. Okay. Now I can go back to what we started with, the sine of the sum, and I can fill in the pieces that I have. My sine of alpha, I've got a square root of 3 over 2. My cosine of beta is 4/5 plus my cosine of alpha is 1/2. My sine of beta is 3/5. And just so we're clear here, this sine of alpha, I'm getting from right here. Cosine beta is right here. They're these values that we found over here. Cosine alpha is right here. And sine of beta is right here. And that's where our numbers came from. Now we're going to multiply. 4 times the square root of 3, 4 square roots of 3, 2 times 5 gives us 10, 1 times 3 gives us 3, 2 times 5 still gives us 10, and I'm going to go ahead and combine over my common denominator. I'm going to write the whole number first, and then the radical part second. I am adding so I can flip those around. I could not do that if that was a subtraction. Just kind of like the whole number first. Okie doke. So here we go, tangent. I would say any questions at this point, but you can't answer me, so email me any questions that you might have. Tangent, you can refer to page 710 and 711 for how we found the sum of the tangents. Keep in mind, tangent is sine over cosine, so tangent of alpha plus beta is going to be the sine of alpha plus beta over the cosine of alpha plus beta. That's why the numerator matches the operation sine, just like sine does. Denominator has the opposite operation, just like cosine. Okay. We've got our combined formula here just to make it super interesting. Tangent of alpha plus or minus beta is going to be the tangent of alpha plus or minus the tangent of beta all over 1 minus or plus tangent alpha tangent beta. Okay, so you can see the sum formula for tangent and the difference formula for tangent look the same, other than how the operations, the plus and minus, are situated in there. So A, we want the exact value of tangent of 2 pi over 3 plus pi over 4. This is the tangent of a sum. So I'm going to start by writing that down. Tangent of alpha plus beta equals the tangent of alpha plus the tangent of beta all over 1 minus the tangent of alpha times the tangent of beta. Now, here's the thing. I don't have tangent listed on my unit circle. I do have the sine and cosine, so I am going to crank those out here. Tangent of alpha is going to be the sine. I don't need alpha. I need 2 pi over 3, don't I? Tangent of two pi over 3 is the sine of 2 pi over 3 divided by the cosine of 2 pi over 3. Sine at 2 pi over 3 is square root of 3 over 2. We're in quadrant 2, so that cosine is going to be negative. I simplify and we get negative square root of 3. We're going to do the same thing with pi over 4. We like pi over 4 because the sine and the cosine are exactly the same. We just need to decide which is positive, which is negative. This is quadrant 1, so both of these are positive. We get the tangent of pi over 4 is 1. So now we're just going to go ahead and plug in my values. Now let's rewrite it in terms of the angles. I got tangent 2 pi over 3 plus pi over 4. I need the tangent of 2 pi over 3 plus the tangent of pi over 4 divided by 1 minus the tangent of 2 pi over 3 times the tangent of pi over 4. excuse me. Tangent of 2 pi over 3 we said was negative square root of 3. Tangent of pi over 4 is 1. I get 1 minus the tangent of 2 pi over 3, which is still negative square root of 3, times the tangent of pi over 4, which is still 1. I am going to reorder my numerator just so I don't have that dangly negative out in the front, and so I have my whole number first, and then I've got 1 minus a negative square root of 3, so 1 plus the square root of 3. And that's it. Okay, again, the time that it takes me to write out the formula in terms of alpha plus beta and then rewrite it with the actual angles is a whole lot less than the time it would take me to spend wondering if I've got the right sine, the right cosine, the right tangent. So take that solid 8 seconds to write the formula out. The more you do that, the more you're going to get used to using it as well.